This is Solution Equilibrium Lesson 2 for the SE2 assignment on dilutions. Consider the following scenario. One day, Mr. Sklar was in the lab and he came across a beaker of copper 2 sulfate solution and a beaker of distilled water. He then, he took the distilled water and poured it into the copper 2 sulfate solution, and boom! That was one of the most exciting things you've probably ever seen. Knowing that molarity equals moles over liters, what variables did Mr. Sklar change when he added the water? Well, when the water was added, the concentration decreased and the liters increased. What variable did not change? It would be moles. We know that when we dilute a sample, that the concentration at the beginning will equal the amount of solute we have at the beginning divided by the total volume. And then at the end, the final concentration will equal the solute that we have dissolved at the end divided by the total volume at the end. If we rearrange the formulas to isolate moles, we wind up with moles initial equals MI/Li and moles final equal MF/LF. We said that when we do a dilution, the amount of solute does not change. So since the amount of solute does not change, moles initial equals moles final. And since moles initial equals MI/Li and moles final equals MF/LF, we can then conclude that MI/Li equals MF/LF. This is not on your formula sheet, so please take the time to add this formula to the formula sheet. Example 1, 12.0 milliliters of a 2.0 molar KOH solution is made to volume in a 500 milliliter volumetric flask. What is the final concentration? Well, what is the final concentration? I'm looking for MF. And it told me I have a volumetric flask, and anytime I have a volumetric flask, that is a piece of glassware used to make a solution. And the volume of the volumetric flask is always the final volume. So liters, since the volumetric flask is 500 milliliters, liters final will be 500 milliliters. Well, that means that 12 milliliters of a 2.0 molar KOH solution is going to have to be the initial. So liters initial is 12 milliliters, and concentration initial is 2.0 molar KOH. Our formula, MI/Li equals MF/LF. I want to find MF, so I will have to divide both sides by LF. The LF on the right-hand side will factor out, and that means that MF equals MI times Li over LF. Now I sub my numbers in, run it through my calculator, and solve. I have 2 sig figs, 3 sig figs, and 3 significant figures, so that means my answer is only allowed to have 2 significant figures, so 0.048 molar KOH is my answer. There is 18.4 molar H2SO4 in the chemical storage room. To do the lab, we need 2.76 molar H2SO4 solution. How much stock solution must be added to a 1.00 liter volumetric flask to make the needed H2SO4 solution? So the volumetric flask is 1.00 liters, and we know volumetric flask is always the final volume. So liters final will be 1.00 liters. We need to make a 2.76 molar H2SO4 solution. So that's the concentration we want in the end. So molarity final will be 2.76 molar H2SO4. Out in the back room, we've got 18.4 molar H2SO4 solution. That is what we have in the back room that we're going to start with. So that's our initial concentration. And we want to know how much of that solution we're going to have to add to that volumetric flask. So how many liters initial do we have to add to that volumetric flask? So MI/Li equals MF/LF. I'm looking for Li this time, so I divide both sides by Mi. Concentration initial and concentration initial factor out. And that means that Li equals MF/LF over Mi. I sub my values in, run it through my calculator, and that gives me 0.15 liters. Now I need 3 significant figures because I'm multiplying and dividing, and all my numbers have 3 significant figures. So my final answer will have to be 0.150 liters, or 150 decimal milliliters. Two things to keep in mind as you work through these questions. A volumetric flask is a special piece of laboratory glassware. Solids can be added to it and dissolved. Distilled water is then added until it is made up to volume. In dilutions, a stock solution is added to the volumetric flask and distilled water is added until it is made to volume. This means the size of the volumetric flask is always your final volume, your liters final. Secondly, be careful when you read the questions. If you are told 20 milliliters is used to make a 100 milliliter solution, your liters initial is 20 milliliters and your liters final will be 100 milliliters. But if you are told 20 milliliters is added to 100 milliliters of water, your liters initial is still 20 milliliters, but your liters final will be 120 milliliters because you added 20 milliliters to 100 milliliters. The total is now 120. And what should be common sense point before you start the assignment? In dilutions, the concentration always goes down. So that means Mi is always bigger than Mf. And since you are adding water, that means that Li is always smaller than Lf. And that brings us to the end of the lesson. Please feel free to work on SE2 now.